Hi, my name is Nathan and I am the leader of the PASS BI virtual chapter, and we have today Eugene who is going to present about DAX. And Eugene is from Pittsburgh, and he you know he does sessions in SQL Saturdays, and he also present in other virtual chapter. So thanks Eugene for coming forward to uh, present in our chapter, and I'm going to make you as the presenter now. And then so here we go. I'm going to make you as a presenter. You can share your screen.
All right.
And yeah, and then one more thing, please ask your questions, and then we'll be watching the questions in our questions window, but Eugene will try to answer at the end of the session. Okay, is it okay with you, Eugene?
Yep, that sounds good to me.
Okay, thank you.
Yep. All right. So let's get started. Thank you everyone for attending today. I'm really excited to give this presentation on an advanced introduction to DAX. So that may seem like a bit of an oxymoron, because how can you have an advanced introduction? And we're going to go into more detail about what that actually means in this case. But the key point is I want to talk about the stuff that's going to be the biggest roadblocks for you to learning DAX. I don't want to talk about the stuff that you can just Google. I want to talk about the things that are going to give you the right mental models and understanding to work with DAX and kind of eliminate those roadblocks. So real quick, a little bit about me. I work as a business intelligence developer, and I've been working for Alliance Technology in Pittsburgh for 5 years now. I've been speaking at our local SQL user group, at various SQL Saturdays in the tri-state area, pretty much anywhere I can drive to in 3 or 4 hours. And recently I've helped lead the Pittsburgh Power BI user group, and hopefully sometime this year I'll be coming out with a course on Pluralsight about Power BI. Now, the reason I mention all this stuff isn't to boast, but because of the fact that whenever I started my job 5 years ago, I really wasn't, from a technical perspective, perhaps qualified for the job. The job was .NET/SQL developer, and I knew a little bit of .NET. I had taken a course or two on databases, and I thought, okay, I've got this. And I remember my first week just Googling, what is a stored procedure? What's the difference between a view, a stored procedure, and a function? And so I really didn't know any of this stuff. I was not very well acquainted with databases, especially the Microsoft stack. And I learned on the job, but I found out about these local user groups. I found out about SQL Saturdays and all these types of events, and started speaking and was able to grow as a speaker and start to give back to the community. So I really want to encourage all of you to look into any local user groups, look into speaking, because it's a really great opportunity for you to grow as a professional, but also to give back. So enough about me. Let's talk about what we're going to cover today. So the goal of this talk, like I said at the beginning, is I want to focus on core concepts. I want to focus on the mental model that you need for DAX, because it's not the mental model that you have right now, most likely. It definitely wasn't for me. There's pieces that are like brain dead, simple, and easy. And then there's pieces that are really unintuitive. And that's kind of the contradiction of DAX. And that's why it's a challenge, because it looks like it's just Excel formulas on steroids. And it is, and it isn't. So we're going to talk about some of those differences. So something that I want to mention is what DAX isn't. DAX is not Excel or SQL or MDX. And if you don't get this into your bones, you're going to be in for a world of hurt, because it's the concepts that are difficult with DAX, not the syntax, not putting together formulas. The concepts are what the real challenge is. And I know whenever I started working with DAX a year or two ago, I thought, oh, this is just like some Frankenstein child of Excel and SQL, and I'm good at both of those, so I'll just mash together those skill sets and I'll be fine. And that is not at all how it worked out for me. And so this is the presentation that I wish someone had given to me 2 years ago, because I would have been a lot better off and I would have had a much better start with DAX. DAX in a lot of ways fails the Google test. simply because maybe there's not as much content, or maybe there's a smaller community, or while DAX itself has been around for, I think, at least 7 years now, Power BI is fairly new, and so I still consider it a newish technology compared to SQL, which is older than I am, depending on how you start counting. So let's illustrate that with a diagram. So this isn't the most artistic diagram, but it'll do. So this is, in my mind, kind of the learning curve for DAX, and it illustrates the problem of when you're trying to learn DAX, because we've got this kind of S-curve going on here, right? So if we start down at the bottom left, this is, anyone who's just brand spanking new to DAX, and the first place you start is some simple functions like if-then functions, Boolean and, mathematical cosine, whatever, and you look at them and you go, oh, this is Excel. I know how to do this in Excel. I know how to do this here. Done, right? And you keep moving along that learning curve, and it only takes a little bit more work, and you start to get the calculated columns, and you're like, oh, this is still pretty simple. It's just like Excel. And then, bam, you bang your head against the curve of learning. You bang your head against this wall, because what happens is with DAX, at least in my opinion, is that the comparison between the functionality that you can do and how much learning and how many concepts you have to absorb dramatically shifts. It just shoots up like a rocket. And if you're not prepared for that, you're going to bang your head against it. Because once you start talking about measures, it gets confusing, because you go, well, wait, I have calculated columns. How's a measure different? And then you start talking about filtering, and some of it makes sense, but some of it gets really confusing, because you say, well, why do I need to use the filter function some of the time? Why do I need this calculate function? And what the heck is all? Because in SQL, I can't just do an anti-where clause that undoes a filter from earlier before. Like, that just doesn't work. And then you start learning about row context and filter context in terms of these evaluation contexts, and your head just explodes. And then it calms down. Like, after that, it calms down again, and you can start learning a lot more of this advanced stuff without nearly as much pain and misery and suffering. But that sharp curve, when you're first starting, is just brutal. And again, it fails the Google test, right? With SQL, you can just, you've got a problem, you Google it, 10 people have already asked it, and it's on Stack Overflow. It's that simple. But for DAX, at least in my experience, that wasn't the case. You really want to invest in a good book, and I'll cover 2 examples at the end of this. But it's a whole different beast when it comes from a learning perspective. So let's talk about how that relates to this course. So this presentation, we're going to focus on that sharp part of the learning curve. We're going to focus on that part that's really a pain and a difficulty, and my goal is, by the end of this hour presentation, I'm going to equip you with all the concepts and the mental models that DAX clicks for you. I'm not expecting you to be an expert. I'm not expecting you to know everything. There's a ton of stuff over to the far right of this curve that we're not even going to touch, might barely even mention. But by the end of this hour, you should have enough of those difficult concepts that you can get started. So that's how we have this kind of contradictory advanced introduction, because I want to teach you all the advanced concepts you need to get introduced to DAX. So let's talk about what's going to be specifically in this presentation and what we're going to go over. So we're going to cover a handful of different things. The first thing we're going to cover is the difference between a calculated column and a measure, because they seem very similar, they seem redundant, and it can be really confusing and frustrating, because you've got 2 different ways to do kind of the same thing, and there's some trade-offs that you may not be aware of, and so it's hard to tell, when do I want one or the other. But these are your basic building blocks of data modeling. These are how you enhance your data model. Next, we're going to talk about columnar storage, and that just means that with the DAX engine, all the data is stored in columns. This is in contrast to SQL, where, unless you're using column store, your data is stored in rows. And that has impacts on performance, but more importantly, understanding why certain pieces of DAX work the way that they do, because a lot of the functions are table-focused and column-focused. And again, if you're coming from an Excel world where you specify cells and you say, all right, cell A1, or you come from a SQL world where you're used to working with kind of fields and rows as the primary unit of measure, this can be painful or frustrating. And that's going to lead into aggregations, where we take a column and we smoosh it together and we get a single value. And that's going to lead to filtering and filter contexts, where we see how filters are applied and how we can manipulate them. And then finally, we're going to talk about iterators, which are our way of overcoming the fact that DAX inherently isn't oriented from a row perspective, but sometimes you need to do manipulations or calculations that are built on a row by row basis. So that's kind of the overview of what we're going to cover today. So let's kind of dig into that first piece. So the first piece is there's two types of business logic. There's calculated columns and there's measures, and we're going to cover each of those. And in both cases, this is your bread and butter. This is how you go from an OLTP system to an OLAP system, how you go from a transactional, just operational data system to an analytical, insight-based system. This is how you enrich the data model. We use this term semantic model, and for me, I find that confusing because it doesn't mean anything inherently to me. It sounds kind of academic when I hear business intelligence semantic model. But a way that I think about it is this is where we add meaning. When I say, hey, gross margin, well, what does that mean? Are we including products, are we including returns, or whatever? Or we're talking about utilization for employees. Well, are we counting holidays? Are we counting certain types of employees differently? Are we counting overtime? Like, how do we think about this? What do these measures mean? So this is how we add meaning. And this is the whole point of DAX, is to add meaning to your data and to organize in a way that you can pull out insights. It's one thing to take a transactional database and just dump in the data. Anyone can do that. The challenge and the benefit of the DAX engine and tabular models is where we add meaning. So this is how we're going to do it. So we're going to start off with the calculated columns. These are more intuitive, especially if you've worked with Excel. So a calculated column represents a single value per each row. And one of the things that's really interesting is these calculated columns are calculated at time of creation and refresh. And so they're materialized. That means they're stored with the table, they become part of the table, they're attached to it, they're there, right? So if you were to look at the table being stored in RAM or on disk in a PBIX file or something like that, in a very real sense, it's part of that table. And so one of the consequences is that this takes up more space. Because if you think about it, if you're materializing those values, they need to be stored somewhere. And so, yes, you get a benefit in terms of CPU because you're not calculating it over and over and over again, theoretically. Instead, you're storing those values. But the downside is it's taking more space. And so if you've got a 100,000 row table, not a big deal. But if you've got a billion row table, those calculated columns can be significant. So that's something to be aware of. Now, a calculated column, it normally only sees the row that it exists in. Okay, and again, I said that rows aren't exactly a thing in DAX, and we'll talk about that more, but this relates to the idea of a row context, which is one of the two types of evaluation contexts, and we're going to dig into that more later. But the important part is just that whenever you have a formula for a calculated column, normally, unless you explicitly specify otherwise with the related function or the related table function or some other function that takes advantage of a relationship, it just sees the row that it's in. One other thing is that calculated columns, something they can do that you can't do with a measure is they can be used in slicers and filters. And additionally, something that's worth mentioning is even though they're a column, you can just drop them down into the values or results area of a pivot table or a Power BI report. And we'll talk a little bit about that more as well. So that's calculated columns. And this is a lot. So let's take a look at kind of a real example. So here's a real example of a calculated column. And this is a calculation for gross margin or perhaps more accurately unit margin in this case. And we're just taking price and we're subtracting cost out of it. And again, if we were to remember that diagram that I made, this part is pretty intuitive. This is before we bonk our head on the steep learning curve with DAX. You go, oh, price minus cost. Got it. Simple. Done. It's pretty much, it works the way that you think it does. And you can see, if you look over there, that we've got this column, and where it's part of the table. It's just part of the table like anything else. It may be displayed slightly differently, but for all intents and purposes, you can treat it as part of the table. Now let's talk about measures, which are different than that. So a measure represents a single value per the entire data model. They're computed at runtime. So instead of being computed whenever you update your data, they're computed whenever the user is kind of demanding the result. And so one of the consequences of this is you're not taking up RAM so much because you're not storing it constantly, but instead you're using CPU. And so it has to calculate those values whenever you're requesting it. And if you change your filters, it has to redo those calculations. And these results are dynamic. So it depends on where in your pivot table or where in your report you're looking, what the result's going to be. So it's not, even though it looks at all of the data, or it tries to, that's constrained by something called the filter context, which we're going to go into more detail, but it's basically all the filters that are applied. And again, the results are dynamic. So depending on what part of your report you're looking at, the same measure could have different results, and it's going to be computed at runtime, whenever the user's interacting with the report. Another thing is that it's not attached to a table. It's loosely associated with a table, and we'll see that on the next slide, what that looks like. But it's not directly attached to a table. It's not a part of a table. And a way of thinking about this is you can have a dummy table that has no rows in it and is just measures. And you can't do that as easily with calculated columns. You could probably do that to some degree, but it's going to be a pain, and you're explicitly referring to the relationships, and it would just be a mess. However, with measures, it's a piece of cake. It doesn't matter. So again, measures see all of the data at once. They're not looking at a single specific row, but they are constrained by whatever the filter context is at any given time. So let's take a look at an example of that. So let's say we wanted to take the total quantity. Well, here we've got our aggregation function sum, and then we're specifying the sales table and the quantity column. And if you look down at the bottom right, you can see that there's our measure, and it's returning the total quantity for all of the data. Again, it's not associated with any specific row. It's looking at all of the data. And again, you could make an entire dummy table of measures if you wanted to. So you could have a table that's just completely unrelated and just measures. Again, very different from how you would work with calculated columns. One more piece on these measures and columns before we move on. I want to talk about implicit measures. So implicit measures, if you drag a column, even a calculated column or a regular one, it doesn't matter, into the values area, like we see on the left for a pivot table, or in the results area for a visual in Power BI, it's going to create a implicit measure. So it's still making a measure. It's still using a measure. So anytime you've got values or value section, you have a measure, but it's making it implicitly. And in Power Pivot and Power BI, you can see over the right, if you go to the Advanced tab and you hit Show Implicit Measures, you can see those measures like the middle right, and you can also see the code that it's created for that. And here, this sum of quantity, the code that it's made, is virtually identical to what we had before. The only difference is it's using those single quotes to escape the table name. But because there's no space or goofy characters, it doesn't have to do that. So that's the last piece I want to talk about for now about measures versus columns. So next, let's talk about what DAX is good at. Okay, because there's some things that DAX does not shine at. If you're trying to do invoices and operational line item reporting with DAX, you're probably doing it wrong. Go use SSRS or Crystal Reports or some other paginated reporting tool. The DAX language has two things, in my opinion, that it is awesome at. It is designed for, from the ground up, aggregations and filtering. And we're going to talk about each of these in detail. But this is really important to understand, because if you're working with DAX, you want to make sure that you're using a screwdriver to twist in screws. You don't want to be using a hammer for your screws, so you want to make sure you've got the right tool. So what is an aggregation? An aggregation is simply, I mean, in plain English, it's just combining a group of values into a single value. So this could be sum, average, min, max, distinct count. There's a bunch more of them, but if you've worked at all with Excel, you're used to this. This makes sense. And the fact that DAX is designed for aggregations has an impact on how it was built. But you think about it, let's talk about Power BI. Power BI is great for KPIs and dashboards. And generally, when you're doing a dashboard, you're taking a bunch of values from a column and smooshing them together in a single result, right? So let's take a look at like what that looks like just conceptually. So here, let's say we have quantity and we're doing a really simple aggregation. We're just taking the sum, okay? If we wanted to do something like this, the most optimal way to store these numbers are together sequentially. And that way, whenever the computer is reading something from disk or it's reading something from RAM generally, it's able to do it faster. It's able to do it more efficiently, and it works better with the caching process. So if you've got something stored in the CPU cache, it doesn't have to keep pulling in extra values just to calculate what it needs. And we'll talk a bit more about this. But so you look at this and it makes sense that if most of the time you're doing aggregations, it makes sense to store the data in columns because that's what you're going to be pulling, especially because a lot of dashboards and things, you're dealing with a single value column and then one or two filters, maybe company or color or product or something like that. I mean, a lot of times I'm talking the simple stuff here. So if you wanted to optimize that, you would optimize for columns. Well, the DAX engine stores data as columns. And so this is really, really efficient for simple aggregations because it only needs to look at just a couple of those columns. Many of these aggregate functions take in columns as parameters. And more so, DAX is optimized for single column operations. So you're going to see a lot of functions where it only takes in a single column. And if you want to do some sort of expression, like let's say you want to do price times quantity to get total price or extended price, whatever you want to call it, you have to jump through a few more hoops. And we'll talk about that. But I really want to get in everyone's head that columns are the bread and butter of the DAX engine. Columns are the bread and butter. So let's get a visualization in our head so we understand this better. So let's say we had a normal transactional table, okay? Let's say this is in SQL Server. Well, if we wanted to look at how the data is stored, we would see that it's stored as a row, okay? If you're dealing with SQL Server, it stores them as 8 kilobyte pages on disk, and it stores them sequentially. Well, let's say I just wanted to grab quantity. Well, if I want to do a simple sum, I have to read this entire row, potentially, unless I have an index or something specifically tuned for that, but let's assume not. I have to read in this entire row, and then I have to read the next one, and then I have to read the next one, and so on. So I have to potentially, if I don't have the any fancy indexes on my table in SQL Server, I have to read the whole table. In SQL Server terms, this is called a clustered index scan. You're reading the entire thing just to summarize a single column. You just wanted to know the total quantity. This gets worse the wider your table is. The bigger your table is, the wider it is, the bigger these rows are, and the more data you have to read in for something where you only cared about 2 or 3 columns. That's their inherent problem. Whereas with DAX, the data is more like this. The columns are loosely associated to form a table, but they're not really together. So instead, I could take that entire column over on the right for quantity and just slurp it up and get my number without having to read anything else. That's one of the big things with DAX. Because we aggregate, the basic unit of measure is the column. And the next basic unit of measure is the table. And a table, again, is basically a set of columns that have the same length and the same sort order and are loosely associated, but really are completely separate entities in some sense, depending on how you think about it. And then the next most common thing you're going to see a lot of times with functions are scalar values, and then finally rows. And a row really isn't a thing per se. It's more a row context, which is an evaluation context, which is basically a filter for the entire table that uniquely identifies a row. And you don't need to worry too much about this, but it matters once you get into more advanced DAX and you deal with things like context transitions or iterators, which we'll talk about briefly, or some of these other things. But the key takeaway, the thing I really want you to understand is that columns are the fundamental unit of measure when dealing with the DAX engine. And let's talk a little bit more about that because that impacts compression and encoding. So whenever you have encoding, whenever you're importing the data into your data model, the DAX engine does a number of changes to make it more efficient. So one is value encoding, which is basically if you got a bunch of numbers, a bunch of integers from 100 to 110, it might subtract 100 from all those so that it can store the delta values, which are much smaller and potentially require fewer bits. Don't worry too much about that. The next one is dictionary encoding, where let's say you're dealing with states, okay, and you've got Pennsylvania, 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 Pennsylvania. Instead of having Pennsylvania every single time and taking up 10 bytes, 12 bytes, whatever, it converts that to, say, 1, and then looks up 1 in the dictionary and pulls out Pennsylvania. So it can be much more efficient that way because it takes up less space. And then the final one, which we're going to talk about more and relates to the fact that things are stored as columns, is run length encoding. And this is dependent on sorting, but run length encoding basically says if I have a run of values, so if I have Ohio 20 times, instead of putting Ohio, 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 you would put Ohio, comma 20. Metaphorically speaking, it's done probably differently on the binary level, but from a practical understanding, what we have is, here in this example, we've got red 4 times on the bottom left. Well, we're not going to take up that much space 4 times. We're going to convert it to a dictionary value and say red represents the number 3, and then we're going to say, and that number 3 shows up 4 times or something like that. So you can get really, really impressive compression ratios when dealing with DAX. And again, if you think about the core value of DAX and the core value add, it makes perfect sense because to me, the cool thing about this is I can take a dashboard that has millions of rows of data and show how the company is doing as a whole and show these high-level aggregations and then slice and dice and filter and do it all on a laptop with 4 gigabytes of RAM because of this intense compression, because of the fact it's stored as columns, because of the fact that it's designed from the ground up for these types of aggregations and reports. That's one of the key value adds of the DAX engine. So the other value add is filtering. DAX is really, really good at filtering. And there's 2 different types of filtering, and we really need to understand the difference because that's going to help you with your formulas. So there's implicit filtering, and then there's explicit filtering. So implicit filtering is everything that the user does. And some of it you may not even be aware of. So the kind that you're really aware of is slicers and the filter box, right? That makes sense. So you put a slicer, you click red, you get 8 for your quantity. And you put color or location into the filter box in a pivot table, and that works the way that you expect it to. Something you may not have ever thought of, and I know I never thought of, is how cell location in a pivot table, or say like bar location for a bar chart in Power BI, also does filtering, and they're functionally equivalent pretty much. And so what's going on here is if we look at the bottom, we can see that even though we aren't necessarily, for that example, applying a slicer, we haven't necessarily clicked the drop down to do a filter manually. Based on the location, it's still applying that filter. And so if you look at the bottom right, you can see the equivalent kind of DAX formula to do the same thing. So that's one of the important things is we've got implicit filtering, which is anything the user does. So that's how you slice and dice your pivot table. It's how you slice and dice your visualizations. But then it's also any filters you've put on there by hand, any slicers, any of that stuff. So anything the user interaction is doing, for this presentation, we're going to refer to as implicit filtering. Explicit filtering is whenever you put it directly into a formula. So here we've got green quantity. So let's say we want to see the total green quantity. We want to ignore whatever the user picked. And so for color, you probably wouldn't do this, but if you were doing some sort of comparison, or a good example is if you wanted to do some sort of year-over-year analysis potentially, or a percentage of total, something like that, that's where this kind of stuff could make sense to override that implicit filtering. And it's really important. So as the way that we're defining it, where implicit filtering is something the user does, explicit filtering is something the formula writer does. Explicit filtering supersedes implicit filtering. And if you look at the bottom, you can see that where normally total quantity takes into account the color. But green quantity says, no, 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 no. I'm going to ignore whatever you did for that one column, and I'm going to just get rid of it. So explicit filtering supersedes implicit filtering. So the filtering context is a combination of all those user filters. And generally, these basic filters are associated with specific individual columns. If you want to manipulate that filtering context, if you want to change it, you're going to use something called calculate. So we saw calculate a little bit earlier, but we're going to talk about it more. Calculate is how you change that filtering context. And the filtering context, as I said, is one of two of the evaluation contexts, which alter how a formula is evaluated. It alters what rows it can essentially see at any given time whenever it's calculating that result. So let's say that we wanted to remove filtering. And this is a good example of where when I tried to apply my knowledge of SQL and Excel, I got really confused because in SQL, you don't have an anti-where clause. You don't have an unwhere clause. So the idea of something that was a filter, but it was an undo filter kind of made my head explode a little bit. It was very hard for me to get my head around. But all is great if you wanted to do one of those kinds of comparisons, if you wanted to do a percentage compared to total or something like that, or if you wanted to make sure that you had a very specific filter and you didn't want the user to be able to accidentally overwrite that or ignore that or affect that, whatever. So all can be used on a whole table or can be used on specific columns. And so for, let's say we wanted all colors. What we would do here is we would do calculate, and then we put in our expression, which in this case is just a simple sum. And then we're putting in any other filters we want to apply. That's how calculate works. And in this case, we're going to use all to unapply whatever filters were on color. And so to understand that, let's take a look at the two examples on the bottom. So on the bottom left, you've got all colors. So here, what we've done is we've got an implicit filter based on the pivot table and the way it's laid out for color. Implicitly, we're filtering on green and red. But with all colors, we're saying, I see what you did there with that green filter implicitly based on how you split it up, but I'm going to ignore that. I want to undo that. And it's important to understand that in this case, we're doing all on sales color. So for any other column, we're not changing anything. So if we look over on the right, instead of filtering on color, we're filtering on product type. And here, total quantity and then all colors is identical because color doesn't come into it and all isn't affecting product type. Now, if we were to do all of just sales, if we got rid of that bracket, color bracket, then it would be 17 no matter how you sliced it and diced it, at least for this table, at least for this value. So that's how that works. So that's how we remove filtering. Well, what if we want to add some more complex filtering? So I mentioned before that you can't work with multi-column expressions without jumping through a few hoops. If you want to do something where you're just comparing to a single column, no brainer. And again, that's because the DAX engine stores things as columns. But here, if we were to take same kind of measures we had before, but instead we want to look at anything where the unit margin, the amount of money we're making on the specific item is less than $1. Well, we've got a simple function or a simple expression. We should just be able to throw that in there, but you can see the error that we get. It's saying, well, you've got multiple columns, but we can only really use one. So thankfully, there is a way around it. We can use something called an iterator. So an iterator produces a row context. It basically, if you're from the SQL world, think of cursors, but less evil, right? You still get that same kind of performance hit to a small degree because you are iterating through, you're looping through these rows. But DAX is designed to be able to handle an iterator here or there. When you start nesting them, then you're in trouble. But that's something a bit outside of the scope of this presentation. So filter, like most iterators, it takes in a table and an expression, and then it returns a filtered table. And then calculate is able to take that and change the filter context. So let's look at an example to get an idea of what we're talking about. So instead of trying to do what we did before, let's say we had a low margin measure where we wanted to see the total quantity only for items where the difference between the price and the cost, the unit margin, or the gross margin, however you want to describe it, is less than $1. And so what we're doing is we're doing calculate, which says, I want to manipulate that filter context. I want to change it. I don't care what the user did. I'm the boss. And then we give it an expression. And again, we're just taking the sum of sales quantity. But now we're giving it a filter expression. We're giving it something that returns a table, and we're going to use that to manipulate the filter context. So filter, we need to give it a table that we're iterating through, because even though it looks like something simplistic, it still needs a table to go, well, what's my row? What's my granular row level that I'm dealing with? And so it needs a table to figure that out. And so we give it sales for the table, and then we give it our expression. We say, okay, go through everything in sales, and if this evaluates the true, return it. Otherwise, leave it out. And so you can see below, only the things where the gross margin and unit margin is $1 or less shows up. Everything else has been filtered out. It doesn't even appear to that sum expression that we're trying to calculate. So let's talk a little bit more about iterators. So iterators process tables row by agonizing row, and so they can be expensive. Now, again, DAX is pretty fast. It's designed to be able to make use of iterators. There's situations where you just need to use them. I mean, even just a simple filter like we did there, where anything where we're dealing with multi-columns, it's going to come up. But there is a performance hit. And again, like I said, once you start nesting them or you're doing really complicated expressions, you can run into some challenges. Another thing to remember is that the more columns that you're dealing with, the worse your performance potentially. And so that applies for when you're importing data, because compression isn't effective because of run length encoding and how that works when you're dealing with multiple columns, or whenever you're dealing with these calculations. In fact, sometimes it'll create a virtual table in a format that's easier to work with if you've got some sort of goofy expression that involves 5 different columns. So bear that in mind. And so with an iterator, like we said, we loop through the rows. They're filtered one at a time. So we're creating a row context which takes the whole table, filters it down to a specific row. And oftentimes you're going to have situations where there's a filter context and a row context applied at the same time. They're not mutually exclusive. And in fact, there's a way with calculate to convert a row context to a filter context. And that's something beyond the scope of this presentation, but I still want to mention it. So when you start talking about advanced DAX, These concepts are super important. Understanding evaluation contexts and iterators, tremendously important. And that's why on my goofy hand-drawn diagram, I had at the very top of that really painful learning curve. I truly feel that once you get evaluation contexts and iterators, a lot of this stuff gets much, much easier. So anytime that you're dealing with one of these multi-column expressions, you're going to be looking at using an iterator. So here we have an example where we try to take sum and we just shove in price minus cost, and that gives us an error that you can see at the bottom. We just can't do it. So let's look at an example of an iterator so we have a little bit better idea of how this all works. So here's a really simple example. So we've got our gross margin, unit margin, whatever you want to call it. In the first example, we're just taking average of a calculated column. So we've already calculated this value. And in the second one, we're taking average X. So I don't know where they got the idea, but they decided that for all of these aggregate functions, whenever it's an iterator, we're just going to slap an X at the end of it. So that's how you can kind of identify it. So you've got sum X, min X, rank X, average X, all these sorts of things. And all that means is we're going to take in a table now and an expression. And then we're going to aggregate it based on which type of aggregate function you're using. So for the second example, we're taking sales. We're taking the sales table. We're going through each row in the sales table. And then we're calculating price minus cost. And then we're going to take all of those results and we're going to apply an average to it. So that's how an iterator works. And if you look down below, you can see that the values are the same. This is functionally equivalent. The difference is we're not having to take up more RAM by using a calculated column. And depending on what our filters are, this can be a lot more efficient just in general, because you might only be looking at 10% of the data based on your initial filter context. And so there's no need to calculate price minus cost for every single row in the data model. So that's just something to really be aware of with what we're talking about. So those are iterators. So that's the bulk of this talk. I just want to kind of run through some of the key concepts, and then I have just a simple suggestion for kind of learning some of this stuff and moving on. So to reiterate kind of the whole talk here, the goal was to give you the concepts that are hard, the concepts that you need so that DAX can click, and so you understand how it all works and how to put it together. I'm not expecting you to be an expert today now, but I am expecting you to go, oh, I think I might get it. And the key concepts I want you to take away is calculated columns are a physical part of the table. They're stored with the table, they take up RAM, they take up disk if you're dealing with like a PBIX file when it's saved. They are materialized, and so they take up space, and they're calculated whenever you refresh your data. Every time you refresh the data, your system has to recalculate these values. And if you have a lot of rows, that could be an expensive process. If you're dealing with a tabular model on an SSAS server, that could really extend how long it takes to process everything if you've got a ton of rows and you're doing a lot of calculations. Measures, by contrast, are calculated at runtime, and they look at the whole data, plus whatever the filter context is at that specific time. They're not living in a row-by-row world. They're looking at all the data. They kind of sit above and see everything all at once, minus whatever's filtered out. Explicit filtering, filtering done by the formula writer, which is probably you, overrides implicit filtering, which is done by the user of the application, whether that's slicers, the report box, or how a report is laid out with regards to pivot tables and most visualizations. DAX itself is a columnar database. It is designed for single column operations. It does those amazingly well and amazingly fast, but you can do more complex operations. Rows, as the way that if you're coming from the SQL world, think of them, don't exist. You've got columns, but row contexts do. These unique filters that identify a single row do exist, and those are important to understand because they're not exactly the same as you would think from the SQL world. They can be manipulated. Multi-column operations. Anytime you want to do something that involves multiple columns, you're going to either be needing to do a calculated column, or you're going to have to do an iterator. And in either case, you're running into a performance expense of some sort. I'm not saying don't use iterators. They're necessary. They're absolutely necessary for a lot of stuff you want to do. Anything more advanced than very basic comparisons to a single column, you're going to want to look at, you're going to need to use iterators, but you want to use them with caution. You want to understand why they can be performance heavy. And then finally, calculate plus something like filter or all can be used to apply some slightly more advanced filtering. There's a lot more complicated things that you can do. We didn't even get into anything with time intelligence or anything like that. But just getting started, those are some things you can do. So that's kind of the key takeaways that I wanted everyone to get with this. And now I want to talk real quickly about where next, what next. So one of the things that I really truly recommend is that you go and you buy a book. That is how I was able to pick this up. There's also an edX course on Power BI which helped a little bit. There's some videos here and there. There's some blog posts here and there, but like I said, there's that really, really painful learning curve, and it's really hard to get this comprehensive picture of how it all fits together on your own. So I would 100% recommend the next thing you do is buy one of these two books. There's a number of books out there on DAX, but these are two of my favorites. The first one is by Rob Colley and Avi Singh, and this is it's by Excel users for Excel users. This is one of the rare technical books that I will say was an enjoyable read. Not to say that technical books are bad, but this was something that I found myself actually enjoying reading. This is something I found myself willing to lay on the couch and read through. And I think a lot of that is the tone, because Rob and Avi have a very lighthearted, jovial tone with their book. You know, some of the diagrams are just kind of funny to look at. It's a very enjoyable book from that perspective, but also just the pacing. It starts out really kind of boring in the sense that, like, you read the first couple chapters and you're like, oh yeah, I got this, this is simple, whatever, and then, you know, it follows that curve only a little bit more smoothly than in my diagram. And so by the second third of it, by like the middle of it, you're like, whoa, slow down. Once they start talking about things like calculate and time intelligence, you're like, whoa. And they do a really good job of that. They do a spectacular job of navigating that curve where at no particular point do you feel intimidated. So if you are brand new to DAX, if you're coming from an Excel background, or you're just looking for like a light, easy read, I would wholeheartedly recommend this book. So that's the first one. The second one is The Definitive Guide to DAX. So this is by Marco Russo and Alberto Ferrari. And this is the guide to DAX. If it were not for this book, I would not have been able to put together this presentation, because this is how I truly started to learn how things work on a deeper level. That being said, you know, if the first book is lighthearted and fun and you can read it on the beach, this is not. This is extremely well written, extremely detailed, but it can feel a bit like reading a book for a certification. If there was a DAX certification with Microsoft, this would be the study guide. And so that's not a bad thing, but you know, you're comparing 500, 600 pages of content over on the right to 100, 200, I forget exactly. So if you're just dipping your toes, get Power Pivot and Power BI. If you've learned that your boss decided that you're using Power BI and you're in charge and you need to start writing some significant formulas, get the one on the right, because this is going to be your reference book. So these are the two books I would definitely recommend. Like I said, there's webinars by Microsoft. There's the edX courses. On the next slide, I have a link to my blog. Specifically, I maintain a list of resources for learning Power BI in general because there's just so much out there, and it can be overwhelming, it can be hard to find everything. And as much as I want you to go to that list, please, please, please buy a book, because there's all these different pieces and they're not as coherent as I would like, and it really helps have a book that just weaves the narrative and ties them all together. So that's the presentation. You can contact me at SQLgene on Twitter. You can contact me at emeidinger@alliancetech.com. I have posted the slides to my blog at sqlgene.com, and if you go to sqlgene.com/PowerBI, I've got a curated list of resources for learning about Power BI in general, part of which includes DAX. And so at this point, if we've got any questions, I'd be more than happy to answer them. We've still got 10 minutes, left some room there for answering questions, but that's pretty much the whole presentation today.
Thank you very much, Eugene, for the excellent presentation.
Thank you.
And I have a couple questions for you, and I start in line. First one is coming from Jay Lee, and says, creating a measure using divide, calculate, and sum. Where does that fit in the learning curve?
Okay. No, that's a good question. So I would say that it's more. Let's jump back to that beginning slide if we can, because that'll be a good kind of reference. So I would say where you see measures, it's around that area. It's maybe it takes up a bigger chunk, because the thing is, doing something like, let's say you want to do a comparison, right? You want to take maybe you want to take the sum of sales amount for your current filter context, and you want to divide it by total sales, like all sales, to get a percentage of total revenue. And in order to do that, you need to use calculate and you need to use all. Something like that is fairly simple. Like, you can kind of ditch your way around that without actually knowing exactly how it's working, and that's how it was for me. But I would say that actually understanding how it works is a little bit further to the right, where you see more like filtering, and a little bit before where you see evaluation contexts. So something that's really simple, where you're just comparing some aggregations, that's a little bit farther on the left of the curve. It's a little bit more manageable. But actually understanding it, feeling confident with it, that requires more concepts and more experience, in my opinion.
Thank you very much. And I would go to the next question, which is, row contexts look very much like row groups in column store indexes. Is that correct?
I would say probably. I personally haven't done anything with column store and SQL. I've heard about them, but I would say that's probably very likely. I know that it's, to my knowledge, column store works off of the same concepts, the same technology. So there's a very good chance, but I honestly haven't had a personal need to do anything with column store on the SQL side, and I should probably dig into that a little bit more.
Thank you.
Yep.
Then the next group of questions comes from the same listener. This is regarding tabular works. When you use SSAS or tabular, or can tabular handle big data?
Sure. Yeah, so that's a great question, and something I want to lay out some context for anyone else who's watching to help answer this question. So we're talking about DAX engine. To a degree, we're talking about tabular model, but there's three places primarily where DAX comes up, and they've got different solutions for different problems. So the smallest scale, I would say, is probably Power Pivot. So you're working in Excel. Power Pivot is an Excel add-on, and so you're living in Excel. Next up, which kind of spans that gap between individual reporting and enterprise reporting, is Power BI. Again, that's a desktop authoring tool. They took Power Pivot, moved it out of band from Excel, made it its own thing. But in terms of publishing, it's being published in PowerBI.com, in the cloud with Azure and all that kind of stuff. And then finally, you've got SSAS Tabular, which is a SQL Server product, and generally lives on-prem, although they do have, I think in preview still, Azure SQL Server Analysis solutions. So before we even get into when you'd use it and if it can handle big data, bear in mind that there's a whole spectrum of uses, from Susan in accounting who wants to just do some reporting in Excel, all the way up to this is our tabular analysis cube for the entire company for our entire general ledger. So bearing that in mind, the first few with Power BI, and especially with like Power Pivot, you can fit quite a bit of data into your laptop RAM because of the powerful compression. And so I would say anywhere personally that you want to be able to integrate multiple different data sources and you're working with Excel, really look into Power Query and Power Pivot, because it makes it very easy to take data from CSV files, from Excel files, from databases, put it all together and manage it. And because it compresses and can fit in your 4 or 8 gigs of RAM in your laptop, it's blazing fast. So that's the first piece. Once you need a centralized solution or a single source of truth, or your CFO decides that he doesn't like it when you go on vacation and his reports don't update anymore, looking at SSAS Tabular makes a lot of sense. And so going to the second question, which is can it handle big data? You know, it's funny, I think the term big data is kind of hilarious, because a lot of times big data is defined by whatever a regular database system can't handle, right? So when people ask, can this database system handle big data, for one definition, by definition it can't. But to give you a more realistic answer, you can definitely do big data with tabular. Marco Russo, if I remember correctly, at Past Summit has a talk, which I think is freely available, on dealing with billion-row tables in tabular. So it can go up to 1 billion rows. Now, that gets really expensive and really challenging. Something that might be more realistic for something you're dealing with is, even with Power Pivot on your desktop, if you minimize how many columns you're dealing with and it's highly compressible, you can have millions and millions of rows working on your laptop. So the same is absolutely true for SQL Server Analysis services. Now bear in mind, with Standard Edition, I believe the memory limit is something like 16 gigs, which is puny. Now, you can easily get 5 to 10x compression. Again, if you've got something where there's a lot of repeated values, there's not a lot of cardinality, or there's not a lot of unique values, you can definitely compress things really, really well. So I would say yes. You're going to use tabular whenever you want to focus on these aggregations and filtering. You can use that from the smallest report with Power Pivot on the desktop to gigabytes and gigabytes of data. You can go up to billions of rows, but that's going to get really expensive. So I would say it can support big data, but that may not be its primary focus. Like if you're just talking volume, it's probably not ideal. It's ideal for stuff that you can compress really well. Okay, so I hope that answered that question. Yep.
Thank you very much. And considering the time, I will have a few very quick questions,
sure,
if I may have.
Yep.
One is coming from John Hohengarten. How do you know when just have to use an iterator function versus the non-iterator version?
Sure. So that's a couple different ways. So one way that I described in the talk is anytime you're trying to evaluate an expression that requires multiple columns, you're probably going to need an iterator. The other thing I would say is anytime you need to ask which row am I dealing with for this expression, you're going to be dealing with an iterator. So that's kind of the simple version. It's just if you want to sum a single column, use sum. If you need to calculate quantity times price minus discount, you're either going to need to sum a calculated column of that value or you're going to need to use sum x. So you'll figure it out just from trial and error, quite honestly.
Thank you very much. Next question coming from Tony Di Pesa. I have found DAX Studio to be very helpful for developing and testing queries measures. Do you use DAX Studio?
I think very highly of it. I personally don't use it just because I work a lot in Power BI desktop, and so that's kind of where I live whenever I'm doing a lot of this work. But it's a very well-written tool. It's a very good tool, and so I definitely would suggest it to anyone here to check out DAX Studio.
Okay. Ben Lazin asking, do you have a code sample for using the TSQL equivalent of a CTE or temp table?
No, I don't have any code samples regarding that. That might be something that'd be a good blog post for me. So feel free to send me a ping on Twitter or something like that. Or shoot me an email, and I'm more than happy to put together an example to show you. Here's what it looks like in DAX, and here's how you do it in SQL. But I personally don't have any code samples regarding that.
Thank you. What was again the name of that billion row tabular? Asking Larry Hennig.
So if we look at the book on the right, the authors here, Marco Russo and Alberto Ferrari, at PASS Summit for 2016, Marco Russo did a presentation. I think it's called like handling billion row data models with tabular or something like that. But if you just take a look at the last year's schedule, I think you might even be able to find it on YouTube, or actually probably the best way to find it, go to SQLBI.com, that's their website, and then click on TV, and they have all of their publicly available videos, and you should be able to find it there. So SQLBI.com, and then on the header bar, click TV. It's a really good presentation. I was able to sit in for it. It was very good.
Very good. Now for closing, that's exactly what I wanted to ask, to show once more your email, because
Yep.
I have a few more questions and our listeners can direct those questions, some technical, and then you can provide answer, I assume.
Yeah, so feel free to send me any questions either to, this is my work email, or again, you can send me a message on Twitter, and I'll be more than happy to answer any of those questions.
I do thank you very much for this excellent presentation, Eugene, and I want to thank all the listeners also joining us and making the community stronger by participation and making the knowledge to spread. Thank you very much again, and have a great day.